So if I remember correctly, in this class, what happened was this was the last slide that I got up to. I also, this is what I forgot to say, I posted also a new lecture videos on YouTube. The ones from last Friday, which was the March 12th. Okay. Just letting everyone know. Excuse me. All right. So this is the last slide we got up to. And again, in this section, we're looking at lines and the slope of a line. I did define what it was last time, the slope, and those notes are posted on Blackboard. And this is something else about the slope. In the past, I really haven't emphasized this too much, but I really should have. So I'm going to start going through it now. All right. So basically, the slope of a line, it's actually called a rate of change. The idea is this, and I'm trying to illustrate with this graph. If you have a line, and let's say the slope of it was m, if you were to increase your x, your independent variable, by 1 unit, then the y variable, the dependent one that is, that's going to increase or decrease. It's going to change, that is, by m units. M, again, is the slope. So for each, if you increase x by 1, your y will change by m. It might increase, as in this case, or it might decrease, depending on the slope. If the slope is 0, which can happen, then y is not going to change at all. And that's really why it's called the rate of change. I mean, you could think of it as, similar to the speed of a car when you're driving, right? If you're driving, say, 10 miles an hour, right? If you increase your time driving, time by 1 hour, your distance will increase by 10 miles, right? If you're driving 10 miles per hour. It's the same idea. I mean, they go more into this idea of rate of change in calculus, but I'm not going to go into that here. So just letting everyone know this is what the slope is. Well, it's an interpretation of it, that is. All right. So let's keep going now. So here's another example with calculating slope, right? Remember, it's change in y over change in x, over the corresponding change in x, I should say. So if you have 2 points, right? 2 different points in the plane, different meaning their x coordinates are different, as here, then you can calculate the slope of the line through those points. Okay, again, I went over the formula last time. So for the first pair of points, right, we could do change in y, so -2. Okay, let me do it this way. Let me get the pen out. This might help. Let me make sure the color of it is good. Purple. So we have -2 minus -4 on top. And on the bottom, right? Let me do it this way. And on the bottom, we not on the bottom, excuse me, on the x, well, yeah, on the bottom actually here. But the x coordinates, we have 5 minus 1. Okay, 1 second, please. We have 5 minus 1. -2 minus -4 over 5 minus 1. Right, and again, this is what I meant by corresponding change. I mean, you do have to be a little bit careful because since you're subtracting, the order makes a difference. And again, I like to keep the coordinates for the same point on top of each other, right? Like 5 and -2, right? They're coordinates for the same point, so they're on top of each other. Same thing with 1 and -4, as you can see. All right, someone had a question?
Yeah, so the formula for this is y2 minus y1 over x2 minus x1, right?
Mm-hmm, that's right.
Okay.
It's, again, I did go over that, last time, but the notes are on Blackboard, so.
Okay, thank you.
Okay, that's okay. You're welcome. Okay, good question. All right, so here we calculate the slope. Again, minus a negative, that's addition. So we get negative 2 plus 4 over 5 minus 1. So that's 2 over 4, which is the same as a half. Okay. And notice here that the slope is positive. That's actually expected. We'll see that today. But if you would, again, here, if you went from this point to this point where your x is increasing, your x coordinate, right? From here you have 1 to 5, right? But what does the y coordinate do? That also is going to increase, right? It goes from negative 4 to negative 2. Negative 4 to negative 2. That's why the slope is positive. That's another way of seeing it. You know, if you increase your x, you go from one point to the other in the direction of increasing x coordinate, the first number. If the y coordinate also increases, the slope has to be positive. So for the second one down here, right, even without this calculation, if I went from 0 to 3 this way, 3 here, the y coordinate decreases. It goes the opposite way, so to say. The x coordinate's increasing from 0 to 3. The y coordinate gets smaller. So we expect the slope to be negative. Okay, so let's calculate it. Yeah?
When you're labeling like x1, y1, x2, y2, it doesn't matter which set of parentheses you're doing, right? Like they can be interchangeable.
They are interchangeable, but you have to do the corresponding change on top and bottom, though.
Right. I mean, like if you were to label, like for the first one, 5 is x1 and minus 2 is y2 or y1, it wouldn't matter.
5 is x1 and minus 2 is y1.
Yeah, and then you label the other ones x2 and y2.
You could do that. You could do it that way. That's right. That's fine also.
Okay, thank you.
Okay. You're welcome. Good question. I mean, you could label it that way if you want. That's okay also. I just thought the way I'm doing it, I thought would be a little bit easier. But again, if you want to label it that way, that's fine. Awesome. Good question. Okay, so from here, we can do 3. Yeah, let me get the pen out again. So here again, we can do 3 minus 0 over, right, 3 minus 0 over 0 minus 3. And when you do that, you're going to get 3 over negative 3. So yeah, we get a negative. In fact, we get negative 1. But again, we expect to get a negative. If you, by mistake, got the top backwards or the bottom, right, you would actually get plus 1, you know, positive, and that would not be right. So, all right. Okay, so let's see. Okay, are there any other questions about this? And again, you want to make sure you do the corresponding change. That's actually what I'm trying to show you with these purple arrows. Okay? But again, if you want to use the formula y2 minus y1 over x2 minus x1, I think is the formula. You could do it that way also if you want. You know, whatever works for you. Okay? All right, so that's us. So that's our example. Okay, let's do one involving a graph. Let's find the slope of this line. So again, here, you can really use any 2 points you want, but you could probably guess that I'm going to use the 2 points here that are labeled, right? 3, 4, and 3, excuse me, negative 3, negative 1. Okay? Okay, good. Now, what am I going to do? Well, so I'm going to do, again, 4 minus negative 1. That's on top. But again, you do the corresponding change. So over 3 minus negative 3. So 4 minus negative 1 over 3 minus negative 3, we're going to get 5 over 6. And that's our slope here. Okay. Good. So that's our slope here. And we do get a positive number. I mean, I was going to point this out in the next slide, but I'll just say it here as well. Well, I'll wait till the next slide. But that's the slope for this one. Okay. All right, that's cool. Are there any questions about this one? Yeah, I really hope this is making sense. So, okay, I really do. So if you do have a question, don't be afraid to ask. If you don't have a question, that's fine. I actually made this graph using GeoGebra. You know, it's free to use. Desmos is also free. So, although I think Desmos is easier to use. Okay. Okay, let's compare now a bit. Okay. So here we have two lines, as you can see, right? I did plot some points, and hopefully, I mean, I hope you can see that. Well, it might be kind of, well, I think everyone can see though that although I labeled it, this point here is the point 1, 2. So here we have 2, 4, and this is 2, 6. Okay. Okay. Now, first, let's get the slope of the green line. Okay, this is figure 1 up here. Well, for the green line, right? What's that doing? That's passing through the points 1, 2, and 2, 4, right? So if we got the slope, what would we have? Well, again, get the pen out. Right? We go 4 minus 2 over 2. Let me see. Arrow just to say the direction. Then we go 2 minus 1. Okay? 2 minus 1. 4 minus 2, right? That's on top. 2 minus 1 on the bottom. And of course, that's 2 over 1, which is 2. Now that's for the green line. Up here, that's this line. All right. Good. Now for the other line, I called it the blue line because it came out blue. Here. For this line,